Hey guys, Hyperion here. Today, we're talking about rogue planets, what they are, what they're like, and whether it might actually be possible to survive or even thrive on one of these drifting worlds. What are rogue planets? Rogue planets can come in all shapes and sizes. The technical definition is a planetary mass object that isn't gravitationally bound to any star, meaning it's not in orbit around any sun. Instead, it's just drifting through the galaxy, completely alone. Some of these worlds probably formed normally around stars and then got slingshotted out of their systems by gravitational chaos or close encounters with other planets. Others may have formed alone from collapsing clouds of gas, kind of like failed stars. Here's the wild part. Out of the roughly 2.2 trillion planets estimated in the Milky Way, scientists think up to 2 trillion could be rogue. That means most planets in our galaxy don't even have a sun. The biggest problem? No sunlight means no warmth. An Earth-sized rogue planet would have a surface temperature between minus 240 degrees Celsius and minus 220 degrees Celsius. That's around minus 400 to minus 364 degrees Fahrenheit, cold enough to freeze nitrogen solid. The only warmth would come from deep underground, leftover heat from the planet's formation, radioactive decay, or possibly tidal forces if it had large moons. So any life would have to live deep below the surface, maybe in subsurface oceans kept warm by geothermal vents. Life on a rogue planet life could start small, as microbes in subsurface oceans. Temperatures there could range from 0 degrees Celsius to 50 degrees Celsius, or 32 to 122 degrees Fahrenheit, perfect for complex chemistry. These organisms wouldn't depend on sunlight like plants do. They'd feed on chemicals such as hydrogen, sulfur, or methane, just like some microbes near Earth's deep-sea vents today. If evolution got lucky, they could eventually form multicellular life, fish-like creatures that hunt, sense vibrations, or even smell hydrothermal vents where nutrient-rich fluids bubble up. They wouldn't have eyes since there's no light to see. Instead, they'd rely on pressure sensitivity, chemical detection, and possibly echolocation to navigate. The ocean might glow faintly with bioluminescent bacteria, flashing in strange rhythms, the only light in an endless night. Could Earth-like life exist? But what about our kind of life? Things that need light, warmth, and open skies? You might think rogue planets could never have that. But there's one bizarre loophole. A black hole. Not the black hole itself, of course, but the accretion disk, the blazing ring of matter spinning around it. As gas and dust swirl in, they get heated to millions of degrees, releasing huge amounts of energy. The disk can shine brighter than a star, bright enough to warm a world at just the right distance. Let's pick a small black hole, about 10 times the mass of our Sun. If a planet orbited it from roughly 50 to 100 astronomical units away, that's about the distance of Pluto to twice as far, it could receive around the same amount of total energy Earth gets from the Sun. The orbit would take hundreds of years, but the planet could still rotate normally, giving it a day-night cycle. The problems. The catch is, the light from an accretion disk isn't gentle sunlight. It's mostly X-rays, gamma rays, and extreme UV. That's basically radiation soup. If Earth were there as is, the atmosphere would burn off and everything living would die instantly. So let's modify our rogue Earth. Give it a magnetic field 10 times stronger than Earth's. to deflect charged particles. At a thick atmosphere, maybe 10 to 100 times denser, to absorb the deadly radiation and scatter the light into safer wavelengths. That gets us closer, but the radiation would still be intense. So let's cheat again. Life here evolves super radiation resistance. Its DNA could repair itself instantly or be made of different molecules entirely. Some microbes on Earth, like Deinococcus radiodurans, can survive thousands of times the radiation that kills humans, so it's not impossible. What that world would look like. Picture the sky, not blue, but deep black, dominated by a glowing ring stretching across the heavens, the accretion disk. It blazes white-blue near the center and fades to orange-red toward the edges. The light bends and twists around the black hole's gravity, making the whole sky look alive. Constant auroras shimmer near the poles. Plants might be dark purple or black, evolved to absorb every photon that survives the atmosphere. Animals could have reflective skin or scales that shimmer faintly under the strange light. Nights would never be completely dark. The black hole's glow would always hang above like a cosmic halo. In the end, could life exist on a rogue planet? Maybe, if it's lucky. In the dark between stars, life might hide deep under the ice, feeding off heat and chemicals, or orbiting near a black hole, about 50 to 100 astronomical units out, with a strong anti-cancer biology.